Welcome to our webinar on how FME measures up for linear referencing. I'm Mark Stokes. I'm with the FME experts team here at Safe Software, here to help you move forward with your LRS problems and any other interoperability workflows you might have.
Hi, I'm Dave Campanis. I'm also with the experts team, working with Mark, and I also try to be helpful.
I'm Dan Eisminger, and I also work on the experts team, mainly on desktop.
And my name is Bo Guo, representing GISTEC Research. We are a safe partner.
We're going to show you how you can maximize the value of your LRS data by combining your data based on location, or as Bo Guo might say, geocoding your assets in terms of LRS, and working with measures. Before we jump in with both feet, let's have a quick overview of FME and how FME can work with LRS and asset data. I have some asset data in a Postgres database and some streets and routes. Here they are. What I want to do is update the assets with the route measure, the offset, and the route ID. So I'm going to open up here FME desktop, and we can start adding objects to our FME desktop. So what I'm going to do first is add in here our Postgres data, and that's going to be my event polls that I pull in there, and when I click OK here, it's going to make a representation of that data table on the canvas I have here. And then I can just check to see that I'm reading that OK with our feature caching. It's pulled in the assets that I've got there in the polls table, and we can see those assets there. And then in the feature information window, we can see those assets are missing the NLF ID, which is the route ID, the offset, and the milepost measure here. So we want to add that in. So I'm going to grab some data from a file geodatabase. There it is. Drop that on my canvas, and we can add that in. And there's that file geodatabase data, and we can run that as well and just check that we're getting the right information that we're expecting in there as well. And I zoom to the extent that's the data we're getting there in the FME visual preview. So now I want to join these two data sets together, and I'm going to use a transformer in FME. I can spell it right. It's the neighbor finder, so that matches up data by the nearest feature to each other. And my polls are going to be the base candidates. That's what I want to attach the information to. And my candidates are the routes. And then here we've got a bunch of parameters that we can play around with in the neighbor finder. But the most important thing I'm going to do here is merge in the attributes from the candidates onto the bases. So that will be including the NLF ID, which is the route ID, and putting those onto the polls. I'm just going to find the nearest neighbor, so that's the first route that is the closest to the poll. That's the one that's going to get assigned there. And again, we can run that, and the neighbor finder will find its matches. And then if we click on one of these features here, we can see that the neighbor finder gives us a whole bunch of interesting stuff about the closest features. It's giving us the angle from the point to that line, what the closest candidate coordinate is, and also the information that we want here is the distance, which is the offset distance, and it's already added in here the NLF ID, so that's great there. Now the neighbor finder actually doesn't really work very well with multi-line features, so what I'm just going to tuck in here is the aggregator to split up the multi-lines into separate objects so that we make sure that we do get all the nearest neighbors in there. So the other information that I want to get is the offset distance. The neighbor finder has given me that, but it's called it underscore distance. So I'm just going to add in here an attribute manager, which is a catch-all tool for fiddling around with attributes. And we can look at the parameters in there. And here's the distance attribute. And so I'm going to rename that. And so that's what we're going to be writing out to our PostGIS geodatabase. Now, one of the things I am doing is I am updating the poll data in the Postgres database, and I don't want to update many of the attributes. So what I'm going to do is I'm just actually going to remove those attributes so that they don't get updated when we do the actual write back to that poll table. Okay, so now what we have is we've got our polls, and each of those polls has picked up the measure from the nearest neighbor there, should have a measure, there it is. And so the neighbor finder has given us the measures interpolated from our routes in our LRS table. And what I want to do there is now add that measure as an attribute in the poll table. So I just need to get another transformer, which is the measure extractor. And that is going to retrieve the measure value from the geometry, and it's going to put it into an attribute, which we will call what are we going to call that? We're going to call that the LRS milepost. Okay, and now what I need to do is just write that back out to my PostGIS table. So I'm going to add a writer. It's going to be the PostGIS writer. I'm going to copy the schema from the original polls table, which is this one up here, and we're going to add that, get that from the polls table that we've already read in, and we can connect that up. Now in the parameters here, I want to do an update. I don't want to insert new records, so I can just click the update field here, and then what am I going to do that update join on? It's going to be the GeoID, and off we go. We can run that. And you can see we're only writing some of the attributes here, and these are the ones that we wanted to update. But if we look back at that table and click on one of these, hopefully what we've got is we've got all the original attributes, and we've got the updated LRS milepost, the offset distance here, and the ID of the route that asset is closest to. So in a nutshell, that's one of the ways that you can do some quick asset data management and using FME just to illustrate how we can build a workflow in FME. So that was illustrating the use of FME Desktop. The FME platform consists of the FME server, where we can automate the data workflows, and also FME Cloud, which is FME server hosted up in the cloud somewhere if you want to have that option. FME has grown from a purely GIS and CAD spatial ETL toolset to encompass a very wide range of data structures. This is what sets us apart, how many different formats that we can work with through our demos. Though our demos won't show all of the data types that we work with here, the methods are pretty much the same when you're working within FME Desktop. So FME can really help you merge data from disparate data sets. For example, you can pull your asset and work order data from an asset management system using a REST or SOAP API, and then integrate that with your GIS system in a similar way to what I was demonstrating just now. We gave a very similar webinar back in 2013, and since that time we've made many improvements to FME, and in particular around the LRS and use of measures. Many of our geometry transformers innately handle measures now. So as an example, the demo I just gave was well under our co-founders Don Murray's 10 transformer limit. It was only 4 transformers. Back in 2013, the similar workflow had a custom transformer with an additional 16 transformers just to help the poor old neighbor finder merge the root measures onto the assets. So we're always improving FME, and FME should be able to help with all your LRS needs. So that's why we're here. SAFE staff and FME are here to help you maximize the value of your data. So what are we going to be looking at in this webinar? Going on from here, we're going to have a quick review of LRS. Then our guest speaker from GISTEC Research, Bo Guo, is going to share some of his perspectives on working with LRS data. Then we're going to work through some brief demos working with LRS, looking at some of the common tasks and other aspects of working in FME with LRS. And as we go along through our presentation here, please don't hesitate to fire off questions in the GoToWebinar question panel there, and we'll be here to help answer those questions for you. So the linear referencing is an addressing system for linear infrastructure. Instead of absolute coordinates, we're using measurements along the linear features to track assets and the characteristics of the linear infrastructure itself. The strength of LRS is that it allows us to edit the characteristics of the linear features without having to edit the geometry. The disadvantages of the LRS is that if you have to edit the route geometry, then you might mess up your events, and we'll talk about that a little later on. So in this example here, we've got a fence, which is referenced to Highway 6, and that asset, the fence, is recorded as an event that goes from the 2 km to the 2.8 kilometer mileposts. We also have the Highway 6 sign, which is an asset. It's a station point-to-point asset. It's at the 2.1 km reference to the Highway 6. And that's what our LRS routes and our event tables are going to store for us. So the linear referencing is used to manage the infrastructure data for linear features along pipes, rails, highways, and power lines. We're managing the characteristics along those linear assets, and FME is going to help you work with those. So the common tasks that people are using FME for in this space are around asset management, stationing points similar to the demo I just gave you there, creating routes and the measures along those routes, adding the measures to them, creating event tables from the geometry, usually from segmented geometry, moving backwards and forwards between LRS and segmented. Dan's going to give us a demo on that. Working with the back and ahead measures, which occur when you edit the route geometry, and also working with the cardinal orientation, which is the kind of general rule of moving, having all your routes pointing in more or less the same direction. So over to Bo for his perspectives on LRS.
Thank you, Mark. It is my great privilege to share a real-world example that my colleague Carol, Francis, and I did for the Arizona Department of Transportation. People typically associate boundaries with area geometries. However, in linear referencing practices, the authoritative boundary definition is often non-polygonal or even non-spatial. Spatial representations are, however, desirable for analysis and reporting purposes. So the yellow line in this slide divides the spatial and the non-spatial domains. The authoritative maintenance district information stored in a non-spatial database system in the operations division. It goes through two main processes. First is the geocoding process that converts the linear location descriptions into line geometries. The second is the polygonization process that transforms line-based into area-based districts. Now, let us take a look at the data involved in this journey. LRS district table defines highway route segments identified by a pair of mileposts with offsets. Notice there is no geometry in this table. District as lines table has geometry in linear string, line string, or multi-line strings with measure. Notice the measure here is route measure that is different from milepost offset. Obviously, the geocoding process cannot pull geometry from the thin air. It depends on LRS infrastructure. So in this case, we need two tables. One is milepost table. So in the milepost table, we have the milepost number. That's typically the numbers you see on the mileposts along highways. And then, of course, you have the route and the corresponding route measure, which more or less, if it's calibrated, more or less along the mileposts in most cases. The geometry, however, in this case can be optional, but typically the geometry is stored as point with measure. The most important infrastructure piece is route. It's a structure, however, it's very simple. It just contains unique route ID representing the particular route alignment. Then with geometry in line string or multi-line string with measure, with consistent measure built across the entire route. So with this infrastructure, we'll be able to geocode to create district as lines. So the polygonization process transformed line geometry polygons into it is actually a non-LRS exercise. The line segments with district information are first converted to points before being processed by the Voronoi diagrammer. So then the result is district IDs or other description associated with this ID with polygon geometry. Here's the example. And the LRS boundaries from the maintenance operational system defines on the left. And notice the begin and end, in this case, represent the milepost with offset, not route measure. Then on the right is the automatically generated polygon designation associating with the district and org in this case. Well, the key takeaway here, I think, LRS bridges spatial and non-spatial artifacts, and that the true power of LRS is about connecting silos. So for this tool, I believe FME is the perfect LRS tool. So I would like to encourage you to check out Carol Francis' talk that is posted on our LinkedIn, on our YouTube channel, Linear Bench. And also encourage you to participate in the LinkedIn FME in Transportation Special Interest Group. Finally, and if you have any LRS needs, I might consider to leverage LRS custom transformers available on the FME Hub. Thank you.
Thanks, Bo. So why LRS? In a segmented model, the segments are the size of the shortest linear event. Plus, point events have to be represented. If an event changes, that is, they change the road width along road element 1, then the geometry has to change. Only one geometry to represent the route, NLE, then all the events are associated to that route. If an event changes along the route, only the event changes. The geometry remains the same. Of course, you do have the problem of what to do if the road geometry changes. That is, the road is shortened by a realignment of a curve. More on that later. So this slide is showing how the geometry can be represented by the linear non-spatial events. So here it shows the speed limits, road widths, their distance is shown from the non-spatial table. And they are drawn, turned into geometry on the original feature. This first workspace, we're going from segments to LRS, and we're starting with the segments, as you can see here, 3 line segments which are discrete, and from this we are creating measured geometry. So here now we've combined to one feature, which has these coordinates and measures, which we set with the measure generator. So the measure is called distance. We can have named measures, and that is creating this shapefile, which can store measures. From here, we're also recombining the attributes to create non-spatial events. Here we're writing out to Excel. We're using, again, a geometry property extractor, line combiner, etc., measure extractor, and to sort out the attributes. You can see from the input, the events are overlapping. So here I'll show you the events and the output. So you can see the lines are overlapping here, although the geometry was discrete at first. This next workspace, we're going the opposite direction. We're taking some non-spatial events, which happen to be linear because they have from and to measures on them. In this case, we're actually working with percentages of the length. So in a simple example, we have a line. Here we are applying the non-spatial linear events. You have from and to values, attributes on them. Here's for the width, road width, and this is the actual geometry here. We are combining these attributes on to the line with feature merger to show it like this. And here we're using the snipper with the option to snip by a distance percentage, which we are setting from these attributes from here, which we already know to be percentages. So the snipper is used on every feature that comes out of the feature merger so that any part can be snipped to a shorter line segment. And here we are overlaying the lines, removing the measures, and our output, which looks like this, which now shows the discrete geometries created from the events information. FME has an LRS toolkit. There are several transformers which might or might not be obvious, which can be used with LRS. They don't all have LRS in the name. The first one's listed there, LRS focus transformers, the measure generator, measure extractor, etc. Those with measures in them. Also the snipper and the length of point calculator. These are the transformers you would be most likely using when working with LRS data. There's also a few LRS transformers which were given to us by GISTEC on the FME Hub. The link is there and they're listed. The LRS geocoder, the event line online, and the event QCer. So QCing your events is key to getting this to work smoothly. Also, some other transformers which might be helpful: the neighbor finder, line combiner, which can create paths, the topology builder, line on line overlayer, point on line overlayer, path builder, path splitter. So some prerequisites now for LRS success. As I was mentioning earlier, you need clean data. So that means your topology needs to be correct. Your segments are noted and they connect. Complex edges have been split at intersections. Watch out for aggregates. Handy transformers for cleanup, be the snapper, anchored snapper. Intersector, topology builder. That's key and the network topology calculator. As Mark had mentioned earlier, one of the things folks like to do with their data is to orient them in a general cardinal direction. So the cardinal orientation, for instance, your data might need to be oriented, say, from south to north, west to east. So this can be done easily with the coordinate extractor to get the first and last coordinates of your lines. And then with a test filter, just test those new attributes you created. You can see the diagram there, the query that's used in the test filter. So it's basically just checking to see if the start and end values are greater or less than the opposite end. And if so, the orienter. By default, the orienter just reverses the direction of the line.
So at the beginning, I gave a flash demo on working with assets. So let's briefly look at that again. Of course, our demos are always working with pristine data, so they work smoothly. But in the real world, that's not often the case. And you might have to often pre-process your data. So in this case, the asset surveys that were taken, the asset coordinates that came in are in this very strange format from the contractor. It's degrees, minutes, seconds, and so that has to be passed out and corrected. And then we would then do the same sort of process that we had in my previous demo, where we would then take those assets, points in this case, and match them to the road network and assign to the assets the measures, the offsets, and the road ID. So I've got a little workspace that just illustrates those extra steps. Here it is. And so those extra steps are here. And I've built a little custom transformer that will interpret those degrees, minutes, seconds in that weird format and convert it to decimal degrees. Then we can create those into a vertex, create the object ID, and then do the neighbor finder stuff and load the data into our database. So the great thing about FME is the FME platform is that we can then automate that on FME server. So if you have contractors who are, say, submitting these asset reports and surveys, you might want to have them do that for themselves rather than delivering you those Excel or CSV files and having you process them. So FME server is a way that you can automate these workflows. This is an automation in FME server where we've set up a little directory watcher, and then this is the workspace that I've just shown you that we can run in the FME server. And even better, what we can do in FME server is build an FME server app. And so this is just a very simple web page that you can quickly build within FME server. And what we can do is we can just drag on to this page the data that we want to load into our database. And then when we click OK, it'll run that and load that data into our database. And if we had to validate that before we took it in, we could write a little workspace that would do some validation before we wrote it into the database. So that's an example of using FME server to automate your workflows. Very cool thing to be able to do. We had mentioned earlier on this idea of back and ahead measures. So this you have to do if you make changes to your routes. And so in this case here, they've moved it from a T-junction, it looks like, to I don't know what you call those little triangles, but close to being a roundabout, I guess. And so now all the routes and the events have to be adjusted by 0.5 of a mile. And so that all has to be accounted for in your event tables when you're working with this data. So that is one of the awkward parts of working with LRS. So now I think Dave is going to give us an example of working with straight line diagrams within the linear referencing arena.
And straight line diagrams are a way of representing your road network or your pipeline network or any other network, sort of route type network, in a sort of an easier to understand way. So basically, we have the route laid out as a straight line from left to right, and then all the events or all the interesting parts of that route are simply laid out along it. It doesn't represent the real world, but it's much easier to understand. Most people are familiar with straight line diagrams in their everyday life from, say, transit maps. Where you lay out the route of the bus and the stops along it, or the train and the stops along it. It doesn't represent the real world, but it makes it easier to understand where, when to get off for your next stop. An example of straight line diagrams in the real world, we have here the New Jersey DOT website, where you can pick your route and it generates a straight line diagram for you that shows you like the crossroads and the traffic lights and the routes and rivers, etc. So I'm going to show you how you can do some of this with FME. Now, if we're working with event tables and a route, it's actually fairly simple. We just take the measures along the route and replace that as the x-axis, and then the events already have the measures from the beginning to the end, and it's quite easy to lay this information out. However, if we're working with segmented data, your standard GIS data, it's a little more complicated. So for that, we've created a custom transformer that's available from FME Hub called the Straight Line Diagrammer. And I'm going to show an example of it in action. So the Straight Line Diagrammer, we have in the workspace here, and it's kind of the core starting point. It has several inputs: axis lines, the cross lines, and the points. Now the axis line that's the route you're interested in. That's the one that's going to lay across the x-axis and basically be the driver and the scaler of the diagram. So in this case, we're taking some road center lines, and we've got some traffic signals from the city of Surrey, where SAFE is located. I'll just show you what those look like quickly. So we have this road map here, and with the traffic signals on. And we want to take this one particular route along here. That's called Fraser Highway. I picked it because it goes on kind of an oblique, so it's good to show how we make everything into a nice straight line. And we are going to extract first the road name Fraser Highway from the routes. We're going to use that as the access line. We're going to throw everything else into the cross lines. And we're also going to take the traffic signals and turn those into the point features. The straight line diagram doesn't work with it, and it outputs what we have here, which doesn't look quite like what our final product's going to be, but basically this is the heart of a straight line diagram. You have the axis line, you have the cross lines, so they've all been sort of normalized perpendicular to the line, and you have the points here. As well, you have the bar graphs that give you the bar name and the bar value for each of the attributes that we were interested in. And those attributes can actually be chosen here in the straight line diagrammer. We picked which attributes we want to graph. So this is what we've got, and it's not looking like much, but it's one thing I should also point out is this is normalized from 0 to 1. So this is meant as a display product. So instead of having an unknown size based on the real world, I've simply gone from 0 to 1 to make this thing a lot easier to scale for output, say, to PDF, which is what we're going to do next. So once we got this information, we have some more transformers that we use just to style it up a bit. When it comes to the bar graphs, we do a little offsetting. We move them down below the straight lines. We generate some labels, both for the head of the graph and the values in between. For the axis lines, we create some labels. We create a page label out of that. From the cross lines, we label each street that's going to cross the line. And we also create some quickie symbols for the traffic lights. And we just output all this into a PDF file. And we use this PDF page formatter, made it very simple. I'm going to throw the title up here, and I'm going to move the diagram into its section there. And this PDF page format, if you're going to PDF, is really quite neat because you can build all the different parts of the page independently and then sort of throw them all together at the end. So the output of this is in a PDF, and you see here, this is the final output. We have our Fraser Highway title. We have the main line along the axis here. We have all the cross streets nicely labeled. We have little symbols where all the traffic lights are. And we have here the sort of events along that route. We have the materials. We have the number of lanes. You see it as it changes, where it changes, and again, road class, road right-of-way width, etc. So it's a nice little tool to create these straight line diagrams. It does require a little extra work. It's available in the FME Hub, or you can just pick it from the quick add as well. Come here, but custom transformers because it's already loaded. Normally it would be in the second section of the FME Hub transformers there. And that's pretty much it for the straight line diagrammer. So far we've seen on how you can work with the LRS data on the FME desktop, and Mark showed you a bit on how to create web apps in Server as well. But the cool thing about Server is it also allows you to automate your workflow. So once you've created the workspaces you need to manipulate your data, you can move up to FME Server and use the automation tools to start them off with triggers, to on schedules, all sorts of things. We're not going to cover that in great detail today, but if you want to find more information on automating within FME Server, there are some resources here that you can click on in the slide deck. That will be a good start for you, and also some demo applications to help you out as well.
So here we are, the beginning of the end of our webinar. So by choosing the right transformers, you can integrate your asset and your LRS data more efficiently with FME. What we've shown you are some of the tools that we have in FME for working with your linear referencing data. There's tons of flexibility in FME. We've shown how to work with assets and export that to your GIS and put the LRS data on that, assigning measures to asset. Dan was illustrating how to switch between LRS and segmented and back. Dave gave us a quick overview of working with line diagrams. You can automate all that with FME Server. And of course, Bo gave us a great overview and his perspective on working with LRS data. So what can you do? Gather your data, choose a couple of transformers to work with your data, automate the process so you can focus on other tasks on a daily basis. There are lots of licensing options for FME, so it's very easy to get started, including getting trial licenses if you haven't used FME before. So talk to us through safe.com/pricing. And with that, on behalf of the team here, myself, Mark, Dave, Dan, and of course our guest, Bo Guo, thanks a lot for joining us, and hopefully you will be working with the LRS data in the safe zone of FME.